All right, so by the limit process, first thing I'm going to do is write the definition of derivative. The limit as delta x goes to 0, f of x plus delta x minus f of x over delta x. Okay, and then from here, I'm going to plug in my function, or that is find f of x plus delta x, I guess I should say, which is, that's f of x. So if I plug in x plus delta x, then that means I'm going to replace x with x plus delta x. So that's 3 over x plus delta x minus 5 minus f of x, which is that, all over delta x. Okay, now it's an algebra question, essentially. We just have one quick step of taking the limit at the end. And in order for us to do that, to plug in delta x at 0, we got to do some algebra. Okay, so this is a complex fraction. Here's my little fractions, the bigger fraction. And if you remember from algebra, we have to multiply by the LCD, which is the product, in this case, the product of these two denominators. So if I were to multiply by the product, top and bottom, which I'm allowed to do, it's a form of 1, then the denominator, nothing really is happening down there. I still got this delta x, and then I got my LCD. In the numerator, when I distribute to this, right, you got to distribute. For the first fraction, this will cancel out. The x plus delta x minus 5 will cancel out. Leaves you with 3 times the x minus 5. And then when I distribute it to this one, the x minus 5s will cancel out, and it leaves you with 3 times the other factor. Okay, and that's the algebra to get rid of your complex fraction. Now, the goal really is, right, to cancel this out because I can't plug in 0 here, or I'd be dividing by 0. So that's ultimately the goal, is to get rid of that. So let's see what happens when I distribute that. Notice how I keep writing limit because I haven't taken the limit yet. So the limit is equal to the limit, 3x minus 15 minus 3x minus 3 delta x plus 15 all over the same denominator. Three x minus 3x is 0, negative 15 plus 15 is 0. Leaves me with just that guy in the numerator, right? So if I just have that in the numerator, I'm going to be able to cancel him out. And then that just leaves me with a negative 3 up here before I take the limit. I'm being a little lazy by not rewriting. Notice what I have in black is my updated, simplified limit. Limit delta x goes to 0. This and this in my numerator, which was the least common denominator. And in my numerator, just a negative 3. So now I'll take the limit, right? Delta x goes to 0. This is gone, so I don't have to worry about it. So really, I'm just plugging it into here. So that's a big 0. And that leaves me with, well, if I didn't get so messy, it was x plus delta x minus 5. And now we substitute a 0 because we take the limit, rather, as delta x goes to 0. That goes away, and it leaves me with my answer. Notice I don't write limit now because I took the limit to get my answer, my derivative, which is x minus 5 times x minus 5, or x minus 5 squared.